Next time a train passes, look down. Not at the train, not at the rails, at what's underneath. Millions of jagged gray stones stretching as far as you can see. The same stones on every track, in every country, on every railway line in the world. We put a man on the moon. We built planes that break the sound barrier. And yet our trains, some of the heaviest machines ever made, still run on a bed of rocks. Why not concrete? Why not solid ground? Why are we still doing this? The answer is not laziness. It's not tradition. It's one of the most quietly brilliant engineering solutions ever built. And it connects the history of railways to the history of the sea in a way almost nobody knows. To understand the stones, you need to understand the problem they're solving. A fully loaded freight train can weigh over 15,000 tons. That weight hammers down with every wheel rotation, every vibration, every curve at speed. Place that force directly on soil and the ground compresses. The tracks sink unevenly, and an uneven track at speed is a derailment waiting to happen. The solution is what engineers call track ballast, those jagged stones beneath the sleepers. The steel rail sits on top. Below it are the sleepers, the horizontal beams holding the rails apart. Beneath the sleepers sits a deep bed of crushed stone. Instead of letting the train's weight punch straight down into one spot, the ballast spreads that force outward across a wide area. The pressure gets distributed. The ground never takes the full hit. The track stays level, stable, and safe. Now, here's the detail that surprises most people. Pick up a piece of railway ballast and it will cut your hand. These stones are deliberately sharp and angular. You will never see smooth, round pebbles on a railway track. That's not an accident, it's the whole point. Imagine tipping a bucket of marbles onto the floor. They roll everywhere. Smooth stones do the same thing under vibration. They shift, slide, and let the track move. Not good when a train is crossing at 100 miles an hour. Railway ballast is crushed granite or quartzite, hard rock smashed into sharp, irregular shapes. When packed together, the edges bite into each other and lock. The whole bed becomes one solid gripping mass that still allows just enough flex to absorb vibration without snapping the rails. A completely rigid track would transfer every shock straight into the steel and crack it over time. The ballast acts like a shock absorber, firm enough to hold position, flexible enough to take the hit. The stones do two more jobs most people never think about: drainage. A track built on solid concrete or bare soil would collect rainwater. Standing water rusts the steel rails and softens the ground underneath. But loose stones are naturally porous. Water flows straight through the gaps and away from the track. A built-in drainage system that costs nothing to run. And weeds. You rarely see plants growing through the middle of a railway track. That thick layer of heavy, sharp rocks makes it nearly impossible for roots to take hold. If plants got through, their roots would break up the soil and destroy the stable base everything depends on. So the stones carry the weight, drain the rain, and block the weeds, all at once. No power, no moving parts, no maintenance for years. Here's the part almost nobody knows. The word ballast doesn't come from railways. It comes from the sea. Centuries before trains existed, empty sailing ships had a problem. No cargo meant the ship sat too high in the water, unstable, hard to steer, dangerous in rough weather. Sailors filled the empty hold with heavy rocks to weigh it down and keep it steady. That weight was called ballast. When ships arrived at port to load real cargo, they dumped the rocks on the shore. Over centuries, harbors across Britain and Europe built up enormous piles of discarded ship stones. When the first railway engineers needed cheap, heavy material to stabilize their new tracks in the early 1800s, those harbor piles were sitting right there. They loaded the stones onto the tracks. The name came with them. Two completely different problems. One pile of rocks. The man most responsible for spreading the ballasted railway across the world was George Stephenson, the father of railways. He came from nothing. His parents couldn't read or write. He taught himself as an adult by paying for night school. In 1825, he opened the Stockton and Darlington Railway, the world's first public steam-powered passenger line. Ballasted stone beds were part of the design from day one. His gauge, the distance between the rails, became the global standard, 4 feet and 8.5 inches, the same measurement as the coal mine wagons he worked with as a boy in northeast England. Most of the world's railways still use it today, but ballast doesn't last forever. As trains pass repeatedly, the stone edges grind down. Fine particles clog the gaps, drainage fails, and the track starts to shift. That's where the tamping machine comes in. It runs along the track, inserts metal tools into the ballast on both sides of each sleeper, lifts it to the correct height, then squeezes the stones back tight underneath. Each sleeper takes under 2 seconds. A single machine covers several kilometers in one shift. Work that used to take crews of workers weeks by hand. Most tracks need tamping every few years. After 20 to 30 years, the stones wear out completely and the whole bed gets replaced. A big job, but still cheaper than the alternative. If ballast needs this much upkeep, why not just build on concrete? Some railways do. High-speed lines in Japan, Germany, and the UK's HS2 project use slab track. Rails fixed onto a solid concrete base with no stones at all. Smoother, more precise, and needs almost no tamping. A slab track can last up to 90 years with minimal work, but it costs 30 to 50% more to build. And once concrete is set, adjusting the track geometry is slow and expensive. Ballasted track can be lifted and re-leveled relatively easily. For most of the world's railways, passenger lines, freight routes, regional tracks, the stones are still the smarter choice. Those gray stones beneath every railway track in the world are not there by accident. They carry millions of tons every day. They drain the rain, they block the weeds, their sharp edges lock together to hold the track in place and flex just enough to absorb the shock. Named after rock sailors dumped in harbors centuries ago, built into the first railways by a man who taught himself to read as an adult, kept running by machines that work faster than any crew of workers ever could. What looks like a pile of old rocks is one of the most proven engineering systems ever built. That's what we do at Unknown Behind Known Things. Find the real story behind the things you see every day and never think to question. Subscribe for more and drop a comment. What everyday thing should we look into next?